Hello and welcome to this episode of Math with Martinez. In today's video, we are looking at factoring all kinds of polynomials. This is in our unit on the fundamental skills of pre-calculus. And I want to go ahead and start by discussing what is meant by this little abbreviation here, GCF. The GCF is the abbreviation for the greatest common factor. And that is going to always be the number one first step that we will take when we are trying to factor any kind of polynomial. No matter what, always, always, always look for this to begin with. So how do we factor a greatest common factor? Well, what we do is we ask ourselves, when we look at the terms, when we look at this term, 24y to the fourth power and a negative 54y to the third, we ask ourselves, what number could I divide both of those numbers by? What is the largest number, the greatest number that is common to both? And ladies and gentlemen, that is 6. 6 is the largest number that can divide into 24, and 6 is the largest number that can divide into that negative 54. And then we also ask ourselves, how many y's could I divide out evenly from both of those terms? And the most that we could divide out of both would be to divide out 3. If we divide out 3, then here is our result. Ladies and gentlemen, our GCF is 6. Actually, let me do this a little bit lower. I'm going to write my final answer down here at the bottom. Our GCF is going to be 6y cubed. And what is left inside the parentheses here is the result after you divide. So what is 24 divided by 6? 24 divided by 6 is going to be 4. And if I have now the opportunity to apply those properties of exponents from before, y fourth divided by y to the third is going to be just a y, a single y, because we subtract those exponents. And then we have over here, right, we have the y cubed over y cubed. That simplifies to just a 1. And what is negative 54 divided by 6? That is a negative 9. So there you have it, ladies and gentlemen. That is the factoring out of a GCF, the greatest common factor. What we now have are two factors, the GCF and the binomial factor. These two, if we were to multiply them, would go back to our original polynomial, but now it is in a factored form where two things are multiplying together. All right, now ladies and gentlemen, step number 2, we are going to look at a difference of squares. Well, what does that mean? What is a difference of squares? What I mean by that is, let me get my color here. All right. We have perfect squares. Perfect squares are those numbers like the following. 1, because 1 squared is 1. 4, because 2 squared is 4. 3 squared gives us 9. 4 squared gives us 16. 5 squared is 25. 6 squared is 36. And then 49, right? Are these coming back to you? 64, 81, 100, and the list actually goes on and on and on. Those are just the first 10. So when we're working with perfect squares, when you see perfect squares in your binomials, that could be a case where we have a difference of squares. And so how do we factor? How do we factor these types? Well, ladies and gentlemen, we look for a pattern. Here's the pattern that we're going to try to be identifying. When you have something that is of this form, some expression that is a perfect square minus another expression which is a perfect square, the factored result will look like this. You will have the square root of your first term and then plus the square root of your second term. That will multiply with that square root of your first term minus the square root of your second term. So look at those factors real closely there. Do you see that they really are very much the same? It's just the sign in between. So let's go ahead and try to do that here. Ladies and gentlemen, I'm looking at 36w squared, and I'm noticing, oh yeah, 36. 36 is a perfect square. And w squared is just, well, w squared. And I'm also noticing 25, that 25 is one of my perfect squares. So let's go ahead and factor. What number squared is 36? That would be 6. And how do we get a w squared? Well, with a w times a w. One of these is going to be plus, one will be minus. And what is the quantity that when squared is 25? That is 5. So there you have it, guys. That is one example where what we were working with was a binomial, right? Two terms, where the first term was a perfect square, and the second term was a perfect square, and the operation in between was subtraction. Because remember, difference means subtraction. And these are the factors. Now, another special kind of factoring that we will come across is factoring the sum of cubes. So let me go ahead and get this highlighted for us. What are perfect cubes? What does that mean? What are our perfect cubes? Let me get my color here. There we go. What are perfect cubes? Perfect cubes are things like, well, 1, because 1 cubed is 1, and then 8, because 2 times 2 times 2 is 8. The next perfect cubed is 27, that's 3 cubed. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. 7 cubed is 343. 8 cubed is 512. And the list goes on and on. So what is a sum of cubes going to look like? So what does that look like? Well, a sum of cubes is going to be some quantity, some expression cubed. And then because it's the sum, it's going to be adding another cube. It's going to be adding another cube. And when we factor that, it will follow this pattern. You'll have the cube root of the first term plus the cube root of your second term multiplied with the following. It would be the cube root, or your x quantity, squared minus the product of x and y, and then plus y squared. Now let me show you with an example here. All right, so we're looking at our example number 7 here. And so it might be helpful to kind of like think about the two pieces here, right? We're thinking about the two pieces here. So what cubed what cubed is h cubed? Well, that's just going to be h. And what cubed is 125? What cubed is 125, y'all? That is 5. So those are your x and y in your rule. Those are your x and y, these two values here. So when we write it all factored out, you're going to take that cube root, or what cubed is h cubed? H. And what cubed is 125? That's going to be the plus 5. Notice this looks just like what we saw here. Same format. Now continuing on, it is to take your first value, right? Those match each other, your x quantity, and square that. In our case, it is h. So we will square that. And then plus our second quantity, in our rule here, erase. Our first and second quantity, we're going to subtract. We need to subtract and multiply those together. So the two values, h and 5, we can write that as 5h because we usually put the coefficient in front. And then plus, if we're following the rule, plus our y squared. Well, our y is 5, so it would be 25. That is how you factor a sum of cubes. A sum of cubes, again, you're going to look for two values that are perfect cubes and are adding together. Now there's one very much like it, and that is down here at the bottom of our page. We have one more here. It's called the difference of cubes. The difference of cubes is going to be very, very, very much like our sum of cubes, but check out the pattern. The pattern is that you're going to have your quantity x cubed, but instead of adding, it's going to be subtracting another cube. And then here would be the factors. You're going to have your x and your y, those cube roots, but they are going to be, when factored, you'll take the difference of them. And you'll multiply that with your x squared plus the product of x and y plus your y squared. So in this case for 11, let me kind of zoom in here a little bit. So in this case, let's pick our values out very carefully. We have something cubed equaling x cubed. What cubed gives us x cubed? That's going to be x. And then we have another something cubed which equals 343. What cubed is 343, you guys? That is 7. So now we're going to plug these two values in for x and y in our factored form. So here's how that would look. You've got your binomial times your trinomial. In your first binomial, you're going to take the difference of those two. So it'd be x minus 7. Then it's going to be your first value, which in our case was x squared. That first little cube, and that's squared. Then you're going to take and add the product of your two values, which in our case was 7 and x. Those are your two cube roots there, or the values that cubed gave us what we started with. And then last of all is our y squared, where the y is the cube root of this number, which was 7. So we're going to take 7 and square it, and that is 49. So there you have it, y'all. That would be the factors that when multiplied together, if you were to take distribution and distribute these, it would equal that expression, that little cubic binomial there. All right, ladies and gentlemen, that's all that I'm going to share in this part of your video. If you have any questions so far, please take a moment to write those down, share them now. And until next time, stay fired up.